the linear function, which is a fancy name for a straight line, but the linear function. Okay. We know all straight lines can be written in the form y equals mx plus b. It's probably the first way we saw straight lines, and we know that, well, m represents the slope or the gradient of the line, and b, of course, represents the y-intercept. So the first time we talked about lines, that's probably how we did it. Of course, another way we tend to write lines is in what's called general form, where we put everything to one side of the equation and make it equal to 0. This is useful for another formula that we end up using called the perpendicular distance formula. So that's why general form becomes handy. There are some standard things. There's actually, you've probably been told this incorrectly. Because you know how they say A, B and C have to be whole numbers? Well, what happens if it's a surd? How do you make it a whole number? You can't. So A, B and C tend to be whole numbers or surds, best that you can do. Basically, we get rid of any fractions that might be involved. You'll notice I haven't put A is greater than 0. We kind of like A to be greater than 0 because I guess it looks neater starting off with a positive number. But it doesn't really have to, I suppose. But as I say, it looks nicer if A is greater than 0. So all right, we're going to find the equation of a line perpendicular to y equals 5x minus 2, passing through 0, 6, and we're going to put it in general form. And the numbers that have been chosen are quite handy because we've got y equals 5x minus 2. It's in y equals mx plus b form, so we can tell the slope of that line straight away. But we want the negative inverse because we want the line that's perpendicular. So the slope we want is minus 1/5. Oh, look, how handy. The point's the y-intercept already. So I can just say, oh, well, that's y equals minus 1/5 x plus 6. That, of course, is not general form. So we shall get rid of the fraction, multiply by 5, move everything to one side, and there's our equation in general form. Lines parallel to the x-axis. So there's a couple of very special lines, which I suppose they are in the form y equals mx plus b, but it's not immediately obvious. If you've got a line that's parallel to the x-axis, then it's simply y equals some constant number. Now, it's still in the form y equals mx plus b, because a horizontal line has a slope of 0. And so it's y equals 0x plus the y-intercept. Well, if it's y equals a constant number, c will in fact be that y-intercept. So, all right, horizontal line, I know it goes through the point 3, 2. Therefore, it must have the equation y equals 2. Because every point on that line has the same y coordinate. And of course, we could also have ones parallel to the y-axis. X equals a constant. So let's use the same point, 3, 2. So this one would be x equals 3. Ooh, 5c.